Hey guys, welcome back to Kerbal Space Program with Oops. Last episode we managed to get a few missions. We left the atmosphere and managed to get into space, and we managed to get a fair amount of research out of that. So this episode we're actually hoping to stay in space a while. Let's get into a nice orbit and see if we can actually pull that off with the limited technology that we have right now. So let's go to mission control. We definitely want the orbit Kerbin mission here. So we need to achieve a stable orbit around Kerbin. All you should need to do is throw yourself at the ground and miss. Throwing ourselves at the ground, not a problem. Missing, we'll see what happens. Fly a vessel up and out of the atmosphere and accelerate parallel with the surface until you're in a stable orbit to achieve this goal. So let's grab that one. And also, we're going to grab this one. To perform this test, activate the part through the staging sequence when all test conditions are met. So we need to be in orbit around Kerbin at 130 kilometers to 140 kilometers. Let's go ahead and try and do that. Now I have already designed. Okay, so here is the ship that we'll be using. The vehicle ship? I don't know. I guess it is a spaceship of some sort. So yeah, I have already designed this and tested it a little bit. We have 3 solid rocket boosters, solid fuel boosters, and a whole bunch of small fuel tanks, which isn't optimal, but it'll get us where we need to go. I did want to go into this last episode a little bit. Let's take a look at the difference between these two engines, because these are kind of the mainstay of this size. So the one that we're going to be using is the T45 swivel, and that actually allows the engine to direct itself. So it can kind of swing from side to side, and so we can actually tip the rocket one way or the other. The T30 isn't able to do that. What this one does is, you can see there the thrust, ASL, and vacuum. ASL is sea level, vacuum is obviously space. So at sea level, the T30 provides a lot more thrust, 205 versus 167 kilonewtons for the T45. So the other difference is the ISP, specific impulse, I believe. That is essentially fuel efficiency. So if we look at the 30 on the right there under engine, we can see that it's the ISP is 265 to 310 on the 30. The T45 is 250, so it doesn't get as good efficiency at sea level, but it gives 320 in vacuum instead of the 310. So it gives a slightly better fuel efficiency. So it all depends on what you're looking for. With this one, we want to be able to use this engine to steer ourselves, because these winglets don't move. So we need some kind of steering, and that's what that engine's going to be for. So we'll fire off these 3 boosters to get us off of the ground and kind of moving, and then we'll shed those and switch only to the swivel T45, and that'll burn off all of this up to, we separate up here. So this stage, which is essentially stage 2, this stage will get this tiny stage up into orbit, and hopefully by the time he is in orbit we can fire that decoupler to get our second mission. And before I see you on the launch pad, if we try and launch this, we actually can't have a vessel over 30 parts with this vehicle assembly building. So what we have to do is we have to use some of those funds that we've already earned, and we'll need to upgrade this, and I just so happen to know that we also need to upgrade the launch pad as well to support the size of this vehicle. We're kind of limited right now, so let's use 50 grand to upgrade that. Ta-da! And we have our rocket. So one thing I didn't go over in the vehicle assembly building is our delta V. Now we've not really concentrated too much on this so far because our craft have been kind of limited in what we expect of them, but now we kind of have to start paying attention to this. This is the delta V available in each stage. Delta V means a change in velocity, so we can change our velocity by 372 meters per second here, and it gives a burn time as well, so that's 7 seconds of burn out of that stage. So our first stage will be expending for 42 seconds, and we should get well, in theory we would get a gain of this much, but because of gravity and air resistance we'll actually get much less than that because that's not taken into account. So it usually takes somewhere between 4,000 and 4,500 meters per second delta V to get into orbit, but that depends on the craft, the design, all of that fun stuff. So this one, although it says 3,600, I'm fairly certain it's better than that. So let's give it a try anyhow. So 3, 2, 1, we have liftoff. Now I've noticed that this rocket likes to pull in whatever direction is pointing up on the nav ball, so we're going to rotate that into position, and we should start going towards the 90-degree line, which it looks like we are. And so we can see that we're slightly tipping over. That's a good thing. 400 meters per second, a little bit fast for this this altitude. What I'm going to do is throttle up just a little bit and let those go. Oh, clean separation. Fantastic. Alright, so let's tip over a little bit more here and take a look at our apoapsis. Alright, so right now our apoapsis is at 60 kilometers. Oh, and so I'm going to change it so that we're not trying to go quite as high, but we're going to extend this out. So if we're pointing further upwards, then we're going to hit an apoapsis here. But since we're trying to go further out, we're going to push that. So we're going to want to burn until this is 130 kilometers. We're doing well on fuel, we can see right here. We've still got more than half of our fuel left. We're pushing that apoapsis out. We'll go further. So we've taken off from here and we've come up and over and almost at our desired apoapsis, and what we'll do is we'll go to 135, and that gives us a little bit of wiggle room if we kind of botch the circularization, and you'll see what that is in a moment. So yeah, we've taken off. I pointed over here. It's over here. We took off and started heading over this way. So right now we're engines off, and we're coasting to our apoapsis. We're coasting to the highest point because that's where we want to burn so that we can circularize around the planet. So what I'm going to do is, since we are in space, we can time warp a little bit until we're a little closer to that apoapsis. And that's probably good. Yep, 134. So what we're going to do now is we'll point prograde, which means forward in our orbit. So prograde is always which way we're going, which way we're traveling. So we'll point in that direction, and we're going to throttle up again. And I think I may have waited a little too long on that, but not a big deal. So we can see here, as we're burning our orbit, and yep, we are now in a stable orbit of Kerbin. So you can see we got to our apoapsis, which was right about here, and then we sped up so that instead of falling back to the Earth, we sped up and we sped up and we sped up until we're completely missing, I said Earth, Kerbin, we're completely missing the planet, so we actually get into this stable orbit. Now, it's not a big deal, but our apoapsis right now is 140 kilometers, and that's just outside of our desired orbit. So what I'm going to do, this probably won't matter according to the mission, but what I'm going to do is point backwards in our orbit and burn just a little bit. So now we're essentially pointing away from which way we want to go, and we can see that on the nav ball here. So all we need is a very, very small thrust, and that's taken that down to 139 kilometers. And so we're going to be in orbit from 135 to 139 kilometers. So that qualifies for our mission. So test TD12 coupler. I wonder if we can do this without actually... No, it looks like we are going to need to decouple. And I didn't want to do that because since we're in a stable orbit here, that's going to get left in orbit, which means it's going to be flying around the planet. I kind of don't want that, but we have no choice but to leave some trash up here. So let's go ahead and stage, and we should get that mission complete, and there it goes. So thus emerges our tiny, tiny craft right here. Okay, so that is our mission complete. Now we just have to get back to the planet and do a little bit of science in the water. So we're currently orbiting in this direction, so we're going to point in this direction. We're going to point backwards and slow ourselves down. So instead of going fast enough to get around the planet, we're going to slow down and essentially deorbit. So, Here we go. We'll start off pretty slowly because I want to land in this sea right here, so I don't want to overshoot and go too quickly. And actually, I'm going to aim for this patch of water right here. Yeah, I'm going to aim for this patch of water right here because it seems a little bit bigger, and we won't have to go in at such a steep angle. So what we'll do is we will detach our motor and fuel tank, and now we just have our little pod. And let's turn off SAS. If I haven't already described it, SAS uses kind of an autopilot to keep the ship in the orientation that it's at. If we turn it off and I turn, then it'll just keep floating like that until I correct the rotation manually. But if I turn SAS on, the computer will take over and we're able to face whichever way we want, and it stays there. So we're going to face retrograde because we want this plate right here to take the brunt of the atmosphere as it comes in. So let's time accelerate until we hit the 70-kilometer mark for the atmosphere. And here we go. I already wonder if I've overshot this. Watch me land on this this little bit of land right here. We'll see how that goes. So let's point retrograde. Let's make sure that we're pointed the correct way into the wind. And here we go. I'm going to time warp a little bit until we hit the thicker atmosphere, which is usually right around here. You can see we're going at 2300 meters per second, 2.3 kilometers per second, which is just south of orbital speed, which means we're going to okay, yep, it's looking more and more like I might land here, but I'm not 100% sure. So at 2300, we're not slowing down very quickly. It's taken a while, but the deeper we get into the atmosphere, the more resistance on our heat shield, and it's always scary, this bit. I'm going to make sure that our drogue chutes are going to deploy first. It just looks so brutal watching these things crash into the atmosphere. And we can see there that's a heat meter showing how much heat, if something gets close to overheating, this begins to show. We made it over land, which is good. We're going to land in the sea. It means a little bit of research. And yep, reducing our speed the whole time, and soon the flames and the fireball will stop. Let's make sure we're pointed in the correct direction. So all of that air resistance has given us a nice aero brake, and we're still slowing down. So I should be able to now fire my drogue chutes. And our main chute. And let's just float on down. And down we go. Alright. Let's get our research, whatever we can get. So this is from the water. Atmospheric scan. Yep, beautiful. Let's get temperature. Yep, let's keep that. What did we have here? Let's reset that and grab it again from the water. There we go, 4 science from that. Crew report? Yep, absolutely, please. Let's get an EVA report from the water. Back in, and let's recover. Okay, so that gave us 27 science. Fantastic. Parts. Okay, looks like we did pretty well there. This is P-Soups after the fact. I'm actually going to put a cut in here and finish up the episode because the next mission is a bit of a doozy. So we're going to be visiting the moon in the next episode, and yeah, it's a pretty good one. So I'll see you guys then.